here's a few more problems, practice problems that look a little bit trickier or a little bit tricky or cause some mistakes, some pretty common mistakes. So I just want to touch on these. So hopefully you can approach any problem and be all right, any of these quadratic equations. All right, so these first two over here are very similar, and it's a common mistake to confuse them. This first one, x squared minus 4x equals 0, it's in quadratic form. It's equal to 0. I have a quadratic piece here. So I do want to factor this. I just have to make sure I factor it correctly, and these two are factored differently. This one, both terms have an x in it. Right? And if they both have an x in it, that means they have something in common. So here we have a GCF where I can remove that common factor of just x, and I'm left with an x minus 4. So GCFs are possible in here, and they're actually pretty common. So I'd always be on the lookout for GCFs, and it works out, something funky happens over here too, or something not so natural, but also very easy to handle. This is one of our factors, so if we bring it over, remember, anytime we have a factor, we want to set it equal to 0. Well, there's nothing to do here. If I just have an x outside, it's just x equals 0. I still have to set this factor equal to 0, x minus 4 equals 0. I can add 4 to both sides and have a positive 4 as the answer as well. So I have two solutions still, but one of them happens to be 0. Okay, how's that different from down here? Well, now this term doesn't have an x in it. And I still have two terms, but I don't have a middle term. So this should be screaming out to you that it's no GCF, but it is a difference of squares. It's just like this guy over here. So remember, a difference of squares is an instance of unfoiling. So in this case, we need identical factors, and one positive and one negative. So this is drastically different from up here, but they both look very similar. So it's easy to make this mistake between when I need a GCF and when I need a difference of squares. Okay, in this case, we'll take our x plus 2 instead of equal to 0. We'll take our x minus 2 instead of equal to 0. So add a negative 2 to both sides. In this case, add a positive 2 to both sides. This one's probably the most elaborate of the bunch. It certainly is not equal to 0, and it might not even look to you like it's a quadratic. I don't see any x squareds hanging around right now. But if I don't see anything else to do, I'm just going to do the operations that are presented to me. Here I have two binomials being multiplied together. Here I've got some distribution I can do. Let's clean this up and see what it actually looks like. So if we FOILed this out, we'd have x squared plus 7x minus 6x minus 42. I distribute over here, you have negative 6x minus 24. All right, now it's looking closer. I at least have a quadratic over here. Now I can see the quadratic happening. Let's group together some like terms. We have, that'd be plus x minus 42. And now we need to make sure that it's equal to 0. Let's shift all these terms and group them all up on the left side. So it's cancel out these. So we need a positive 6x. Right, that's going to group up with my x term. I need a positive 24. That's going to group up with my other constant term. Now both of these are going to be gone. We're left with a big 0 on the right. X squared would be plus 7x. And those two group up to be negative 18, I believe. All right, now we've got a perfect, nice looking quadratic. That's x that can be unfoiled with 9 and 2. 9 times 2 is 18, and 9 and 2 can group up to get 7 as long as we have positive 9 and negative 2. All right, take each little factor. negative 9 to both sides, and add a positive 2 to both sides. And this last one might look even worse to you with all the fractions hovering around, but there's a nice trick that I believe we've talked about before. And if I have fractions at all in my equation, I can get rid of all those fractions in one fell swoop if I figure out what that least common denominator is. And I just multiply every term in the whole equation by that common denominator. So the common denominator between all three of these terms looks like it's just going to be 2. So I'm going to choose to multiply this problem by 2, this term by 2, and this term by 2. Notice I put the 2 in the numerator because that's what it's being multiplied by, because if I wanted to think of it as a fraction, it'd be 2 over 1. So the 1 is going to the denominator. You're never going to take something, if you're multiplying every term in the equation, you're never going to multiply it by the numerator and the denominator. It's just going to be, I'm multiplying this term by 2, so it's strictly in the numerator, because again, it's 2 over 1. And the reason why this helps is because this 2 that's in the numerator is going to cancel out with the 2 in the denominator. So I'm effectively canceling out this denominator. Same here. So we're left with x squared plus 3x is equal to 5 times 2, 10. And so we effectively eliminated those fractions. Did have to multiply over here by 2 because there was no canceling that happened. So we have x squared plus 3x up. It's still not equal to 0, almost, but we can fix this by adding a negative 10 to both sides. This negative 10 does not group up anywhere, so it's just x squared plus 3x minus 10 equals 0. And now we're game time to factor. This gets unfoiled. Multiplies to 10, adds to 3, that looks like a 5 and a 2. Plus 5 minus 2. Separate. Add a negative 5 to both sides. Add a positive 2 to both sides. And we have our 2 solutions. Alright, so there's some trickier situations. They're all quadratic in nature, but sometimes problems don't look quadratic at all. You just have to do the operations that are there and boil it down into a problem that we know how to solve. So that's the name of the game for algebra in essence anyway. Anytime I see something I don't understand, can I make it look like something I do know how to understand? And then we'll solve the problem how we know how. So just because a problem looks new doesn't mean you don't know how to do it.